Let's talk a little bit more about this example. Everybody looks a little puzzled here, hoping they understand why before Mo is weeping when he pulled the number 2 out of the urn. Suppose that there are 5 balls in the urn. What's the probability that he's going to pull out the number 1? It's a fifth. The probability that he'll pull out the number 5 is a fifth. So those are the numbers that he could see, and that's the bit. Each one is one fifth time. Would he ever guess, as the number of balls in the urn, a number smaller than the one he has in his hand? No, it's an impossibility. Right? Because I told you they were numbered consecutively, and I might be a grumpy old king, curmudgeon, but I don't cheat. Okay, so we would never draw out a 3 and then guess 2. I don't think. Suppose he reached in, he switched around, and he drew out a ball with the number 5 on it. Would he ever guess 6? Why wouldn't he guess 6?
Because if you guess 6, that would imply that the odds of picking a 5 are only 1/5. Not 1/5.
The probability, not the odds.
Sorry, it's a probability. So the 5 is maximum. If you estimate or if you estimate that makes the odds of n, the probability of n being equal to 5 is possible.
Everybody get it? He wouldn't, suppose he reaches in, he pulls out a ball with the number 5 on it. Would he ever announce to the king that there are 6 balls in the urn? No. Because the probability of pulling out a 5 when there are 6 balls is only a 6th. The probability of pulling out a 5 when there are 5 balls is a 5th. It's a bigger probability. But, and we said that the maximum likelihood estimator is that rule which makes it most likely to have actually gotten the observed sample. Why? The average has nothing to do with this one is the largest number. The maximum likelihood estimator is the rule that makes it most likely to have observed your sample, which doesn't preclude the possibility that the phone puts his hand in and he pulls out a ball and he starts to weep. Right? He squishes his hand around in there and he knows clearly there are a lot of balls in there, and he pulls out the one with the number 3 on it. And now he's in trouble. Ex ante, before he looks at his estimate, the rule is you announce the number that you see. Once you see the number, you might change your mind. Because you can look at the number and you can say, I know that number is wrong.
Now, if they're all consecutive, then you have to, for the average, the first time they were consecutive.
Yeah, the first time they were consecutive, 300 times. So, but then, even then, suppose I only allow you to pick one ball. Right. You're still going to announce that number as your best guess for the mean. That's the rule. But are you going to stick to it when you pull it, when there are a bunch of balls in the urn and you pull one out that says 2? Are you going to stick to the rule? No. Then you might as well guess wild. Because you know for sure 2 is wrong. So how good? You buy into his estimator now? You agree that guessing the number showing on the ball is the best guess. It's the maximum likelihood. You agree there? We don't even have to do all the fancy math to figure it out. When we talked about the Poisson probability distribution, the Poisson probability distribution has one parameter, the rate parameter. Remember that? The Poisson probability density is e to the minus lambda Vx over x factorial, right? And the expected value of a Poisson random variable is lambda. The variance of a Poisson random variable is lambda, right? So that said, what do you think your maximum likelihood estimate for lambda is going to be? No, you get to pick a sample of some size n. So you have to draw a sample of size n out of my big barrel of Poisson distributed random variables. They all have been drawn from the same density. So now I'm asking you, what's going to be your maximum likelihood estimated for lambda, the rate parameter? Lambda is what you're trying to guess, but you get to draw a sample and make a guess. So how are you going to use the sample to make your guess for lambda?
The first skill for reason that it's more likely
Yeah, that part I know. I can do arithmetic till the cows come home. I can do algebra and arithmetic all day long. What I want to know, I want to have an intuitive sense of what's going on. Because once you have the intuitive sense, then you can use the same intuition in many other circumstances. And you can decide whether or not the algebra that you did was right, whether it's consistent with your intuitive sense of what's going on. So that's why. So what's the color of your jacket? Let me ask you a different question. I nailed you before. This time, what's the procedure by which we derive the maximum likelihood estimate? You've already told me twice, so tell me again, and I'll do it again, given that I nailed you the first time. We write down the density at every sample point, multiply them all together, so you have the intersection of that sample, and then take the derivative with respect to the unknown parameters, set them to 0, and solve for the parameters.